Hello and welcome to today's webinar. It's Scale Out, Not Up with Distributed SQL Transition to the Cloud Without Compromises. Simon Ambridge, our Senior Solutions Architect from NewODB, will be leading today's webinar. So without further ado, I'll turn it over to Simon.
Thank you, Sam, and hello everyone, and welcome to today's talk. My name is Simon Ambridge. As Sam said, I'm a solutions architect for NewODB, and I'm based in the UK. In terms of my background, my career has been largely spent in database technologies and distributed systems, and my role at NewODB is to help organizations understand how they can migrate their transactional workloads to the cloud. Today, I'll be talking about how to scale out and not up with distributed SQL and how to transition your applications to the cloud. I'll describe some of the technical challenges that organizations face in today's increasingly competitive marketplace, where the quality and availability of the services that you provide to your customers is critical to commercial success. We'll look at how you can build web-scale applications using a database that meets customer demands for application availability and agility, how you can use a distributed SQL database as your on-ramp to the cloud, and how you can lower TCO and improve performance for business-critical applications. Today's event should run for about 30 minutes, and I'll be more than happy to take questions at the end. So if you do have any questions, please raise them in the chat, and we'll pick them up later. Excuse me. So, starting off then, onto the first slide. Organizations have for decades relied on the same traditional and monolithic databases to run their core business operations, but these products were never designed to support the requirements of modern business architectures. Modern tools and technologies allow developers to design and build web-scale microservices and container-based applications, and these distributed applications require a distributed database to support them. The non-scalable, centralized databases just don't work in this type of architecture and, in fact, become a limitation. If you want to migrate business-critical applications to the cloud, they need to be continuously available, able to scale out and in on demand, and they need to be agile enough and flexible enough to maintain compliance with changing regulations. So while legacy database technology powered much of the applications to date, experts like yourselves need to be able to identify solutions that enable you to both reduce technical debt and increase business agility. And I'd like to start by highlighting the two big themes that emerged in 2019, and they're reflected in the graphic from 451 Research. The first is that organizations are increasingly looking to cloud and hybrid cloud and multi-cloud as a means of increasing business and technical agility and reducing costs. And secondly, the massive technology wave that is the Kubernetes ecosystem continues to evolve and expand. And these trends are reflected in the 451 analysis, which suggests that during the course of 2020 and 2021, roughly 75% of primary workload deployments will be away from on-premise and instead delivered onto cloud architectures, and that 95% of those new applications will be built using container technology. Organizations, they want to be able to grow, they want to, without being held back by outdated and poorly utilized resources, and they need flexibility in order to be able to adapt quickly to market changes and demands. And cloud introduces a way for them to do that by offering significant benefits compared to the on-premise infrastructure model. But this trend towards cloud adoption is also due to the fact that the way that developers work is changing. Application developers have more influence in workload deployment now than ever before, and the uptake of containers and container orchestration is increasing. So moving on to the second slide, digital transformation is causing major changes in the way that organizations deliver goods and services to market. 2/3 of organizations say that competitive market pressures are the main reason for them transforming their IT infrastructure and driving business innovation. So in a changing and competitive market, organizations need to be able to optimize every process and every operation in order to gain some advantage to stay ahead of the competition. And there's a constant need for innovation to find new ways to satisfy customers and to be able to differentiate yourself from the competition. Some of the established and long-standing businesses are already finding themselves competing with increasingly capable online service providers who are unencumbered by any technical debt. And that's forcing the established players to adopt new operating models to ensure that they can stay competitive. And one of the major drivers forcing organizations to invest heavily in digital tech and support for mobile, web, and digital platforms is the increasing importance of customer experience. Unlike the designs for traditional closed internal systems of the past, modern digital reference architectures need to be designed to accommodate new consumption channels and to enable collaboration with an ecosystem of partners and third-party interfaces and APIs. And the challenge here for businesses is that they need to remain competitive. They need to transform their outdated legacy systems, and they need to commit to the technologies that will deliver a richer and more productive online service. But to do that, they've got to first predict and then invest in the technologies that they believe will prove to be the most disruptive and offer them the greatest opportunities for innovation. And thankfully, selecting the right tools and the technologies and the providers is becoming much easier thanks to emerging standards for microservices and containers and container orchestration and Kubernetes, all of which are widely seen as the cloud technologies that can deliver the agility and the flexibility and the elasticity that's needed to deliver modern online services. For some industries, containers also promise the portability and cross-cloud compatibility that's absolutely essential for them to be able to demonstrate vendor independence for regulatory compliance. And just as importantly, containers provide the ease of configuration and deployment and operational management that development and operations teams are looking for to be able to efficiently scale and manage their services. So why move from on-prem to the cloud? Onto the next slide, please, Sam. The benefits that cloud promises range from financial to operational, really, but generally accepted, these are a reduction in operating cost, or TCO. You get to make much more efficient use of compute resources, paying only for what you actually need instead of over provisioning for peak capacity and then leaving that capacity idle for most of the month, and then duplicating everything onto a DR site that frequently sits idle for most of the year. You can introduce scalability into your designs. You have the ability to add more capacity to your application as workload increases. And correspondingly, you also get elasticity because scalability needs to work in both directions. So we need the ability to flex capacity up and down as demand for transactional throughput goes up and down. Cloud provides high levels of resilience too. So availability is also much improved in the cloud model. Cloud native and distributed architectures open up the opportunity to achieve things that weren't previously possible with centralized and monolithic applications. For example, active-active applications that are distributed across multiple data centers and clouds, providing a vastly more resilient architecture for your applications. And for this reason, cloud resiliency is expressed in terms of continuous availability and disaster avoidance, rather than just high availability and disaster recovery. Obviously, it's much, much better never to have a disaster from which you need to recover. There's also often a greater degree of control at a business unit level versus traditional IT when deploying applications to cloud. In many cases, cloud allows business units much greater freedom to design and build their own applications without the delays and extended timescales that are often associated with centralized IT projects. And in many cases, IT spending for cloud-based projects moves from CapEx to OpEx as resources are consumed on demand. And this can also lead to more spending flexibility. But organizations are desperate to adopt these leaner, more flexible and cheaper ways to manage their applications and gain a competitive advantage in their market. As part of this digital transformation, we're seeing a move from on-premise infrastructure towards public cloud. Developers are moving from an industrialized IT model to a more agile DevOps type culture. We're seeing the adoption of microservices and containers away from centralized and monolithic expensive engineered appliances and individual expensive servers. But for those distributed services, those microservices and container-based applications, those always-on and distributed applications, there's a big need to move to a distributed database to support them. And what we hear from customers is that they want to move to cloud to explore the benefits that come from cloud, but What they don't want to lose is their investment in skills and knowledge and business logic that relies on SQL and ACID transactions with immediate consistency. What they really want is a distributed SQL relational database that allows them to operate in the cloud and can exploit those container-based architectures. So how does a modern architecture allow applications to be more agile? Onto the next slide, please, Sam. So the Kubernetes platform abstracts the user and provides the orchestration and the scheduling capabilities that are needed to run containers at scale. And cloud native isn't just about containers, of course, but includes all the other offerings in a rich ecosystem of microservices and service meshes and serverless functions, etc. And all of these can be independently updated and controlled and scaled or reconfigured to deliver a transparent and coherent end-to-end application experience. But Kubernetes can really accelerate the benefits that come with containers, not just in terms of agility and scalability, but also via interoperability by supporting integration with other cloud components, and also operational management support that makes continuous development and integration possible. You know, containers have been great for developers and system administrators. They support a very agile method of developing and deploying applications using these latest CI/CD methods, and that's continuous integration and delivery methods. And that increased efficiency allows businesses to innovate and bring changes to market much faster. And containers also make very efficient use of hardware resources. They package applications in a way that keeps them isolated from the host system. And the strong isolation of containers allows multiple teams to run applications in environments that are securely isolated from each other. And that strong isolation on the same shared infrastructure makes much better use of available resources and leads to a greater computing density at a lower cost. So with all of this in mind, there's a really strong belief that containers generally hold the promise of delivering real IT transformation. So at the start of the cloud journey, on the next slide, we saw previously that by 2021, it's expected that 75% of new deployments will be in a cloud environment, whether that's private cloud or publicly hosted. Research also shows that whilst most organizations are moving or anticipating moving away from on-premise non-cloud infrastructure, there's still a need to overcome some of the expected barriers to cloud uptake. And these barriers can include things like inertia, just a reluctance to remove or decommission all those tried and trusted and reliable legacy systems. There's also caution, an aversion maybe to risk and lingering suspicions about cloud security. And significantly, skill shortages are also a problem for some organizations. And in fact, 50% of companies reported a lack of key skills in cloud platform management and security. But in terms of physically migrating applications to the cloud itself, organizations typically follow 3 stages of cloud enablement and adoption. The initial rehost or lift and shift model, you simply run the existing application in a cloud environment. This just moves the on-premise application to the cloud, but makes little or no change to the stack to enable the application to use any features of the cloud. The second stage is to re-platform applications, rebuilding them to benefit from some of the available cloud features and capacity. And then the third stage is to start building applications as cloud native, an application that takes full advantage of the scalability and distributed deployment that's available in the cloud. And cloud native applications can now be built to take full advantage of cloud capabilities and features like auto scaling and load balancing and automated day 2 operations using Kubernetes operators, something which is going to play an increasing part in the management of Kubernetes applications. So looking towards the next slide then with an on-ramp, how do we provide an on-ramp for organizations? So those that are migrating applications to cloud platforms will have different requirements, different aspirations, different constraints, timescales and budgets, etc. So while many organizations are already in the process of developing and deploying web scale and cloud native applications, others are at the outset and considering which technologies and platforms to adopt. Not all organizations will want to be entirely on public cloud. Some workloads and data may never be suitable or an option for deploying on public cloud. And whether you'll want to build out your private, public, or hybrid cloud, it's essential to select a database that can support any of those deployment models. A distributed database is the backbone of a distributed application. So obviously it's crucially important that your SQL database has the flexibility to support it. Now, NuoDB is platform agnostic and cloud agnostic, so it's tremendously versatile. It's container native, but it also runs on bare metal and VMs. This means that you can start on-premise with a cluster built using VMs or containers or a combination of both. And then you can, when you're ready, you can stretch out to the public cloud with the option to add capacity in one or more public clouds. And this deployment flexibility gives organizations real choice in how and when and where they can build a distributed application, and gives them an on-ramp to the cloud, or gives an on-ramp to the cloud for those organizations that aren't quite ready for public cloud, but want to build an application architecture now around a database that can take them to the cloud when they're ready. And NuoDB provides that. As I mentioned, you can start off on premise and stretch out to the cloud, and then ultimately you could decommission the cluster components that are on premise and exist entirely in the cloud. So NuoDB really gives you the opportunity to take your database with you to whatever platform you decide to use. On to the next slide, please, Sam. So banks of all sizes, for example, around the globe are migrating their critical banking applications to the cloud so that they can take full advantage of the continuous availability and increased scale and agility. And to migrate those OLTP workloads, they need a cloud-native, distributed SQL relational database that's architected for mission-critical applications to enable them to run in cloud-scale environments. What they need is a relational database that provides their application software with the ability to scale out and back in responsibly based on demand, a database that provides continuous availability and built-in redundancy, and importantly integrates well with modern tools and technologies like microservices, containers, and Kubernetes. And this is the problem that NuoDB solves. NuoDB's distributed SQL database provides a solution to this problem and enables organizations to overcome the complex challenges that they face when trying to move enterprise transactional applications to the cloud. NuoDB gives them a cloud-native, cloud-agnostic solution that supports any deployment model, whether on-premise, in private clouds, in public or hybrid clouds. To an application, NuoDB appears just the same as any other enterprise database, but under the covers, it's a fully distributed SQL relational ACID compliant database. Next slide, please, Sam. So NuoDB works by taking the traditional or legacy monolithic database architecture that effectively places processing and storage together in the same unit, and it decouples them into two separate layers. And these two separate layers separate transaction processing from storage using transaction engines and storage managers. So TEs are responsible for processing and parsing and optimizing and executing SQL transactions, and the SMs, the storage managers, are responsible purely for the persistence of the data to disk. And this separation allows each layer of the NuoDB architecture to be scaled independently. So TEs can be added to scale out horizontally for periods of peak load, for example, and then easily scale back down again when not required. And SMs can be added to increase resiliency or redundancy, or to extend into another data center or cloud, or to enable data locality, or to support data sovereignty. But this gives us a horizontally scalable, fully resilient SQL database architecture. And in terms of deployment options, NuoDB is available on everything from bare metal to VMs and in Kubernetes-based environments, including GKE, AKE, etc. And of course, runs very well under container management platforms like OpenShift or Rancher, to name just a couple. And it's this cloud-agnostic flexibility of NuoDB that enables organizations to avoid cloud lock-in and to choose one or more than one cloud service provider for their deployment. Next slide, please, Sam. So let's look briefly at some typical application types and how they might each be architected with NuoDB's flexible distributed database. The first is an example of a typical web or mobile application. So it comes with primarily a very high concurrency of database reads and a corresponding high cache usage. But as workload increases, which is mostly simple queries, you can support that increased workload by just scaling out the transactional layer by adding more TEs to manage that increased throughput requirement. In contrast, an OLTP application would have a greater mix of writes as well as reads and would make greater demands on CPU and I/O. And in this example, yes, you can add TEs to scale out the transaction processing capacity as in the previous example, but you could also scale out the storage layer independently to reduce I/O contention. And on to the next slide, please. We've got a couple more examples. In this third example, we're looking at a typical insert-heavy workload like logging or time series data, and this is more likely just to place a heavy demand on I/O. So in this sense, again, you can add more capacity at the storage level to distribute the storage processing. And in the last example, which is a simple example of an HTAP application, so it's a mixed, a hybrid transactional and analytical processing. So this is where the workload profile is composed of a mix of writes and reads, but also a mix of analytical and transactional processing. Now you can easily separate workloads with NeoDB by dedicating certain TEs for one function like OLTP, and other perhaps larger capacity nodes can be dedicated towards the sort of complex compute analytical operations. And this workload separation is very straightforward to achieve, and it's a very effective way of separating workloads within NeoDB. The next slide, please, Sam. So with the key takeaways that I'd like to remember from today's talk are that NeoDB is a distributed SQL relational database that offers a flexible and distributed active-active architecture to give you 100% uptime and continuous availability. You can scale out in a linear fashion. You simply add more transaction engines to scale your throughput in times of peak demand, and then you can elastically scale back down again when the load reduces. And if you're a Kubernetes user, you can also benefit from the NeoDB operator that automates and manages much of the day two or day-to-day deployment and management operations. So finally, being able to migrate enterprise transactional workloads to cloud. Sorry, the next slide, please, Sam. So yes, being able to migrate your workloads to cloud whilst at the same time avoiding vendor lock-in, that's essential in industries where regulations continue to evolve and in some cases already require deployment in more than one cloud, like financial services, for example, banking applications. NeoDB makes it much simpler for organizations to choose how and when and where to deploy their mission-critical applications. And as an example, NeoDB has partnered with Temenos, who are a leading provider of core banking software, and to enable their customers to deliver cloud-based services using the elastic in-memory and active-active features of NeoDB. This partnership gives the global banking community much greater choice of next-generation cloud-native and container-native deployments, and the net is that our customers can migrate critical OLTP workloads to the cloud whilst maintaining an always-on service and benefiting from significant operational cost savings. Now that brings me to the end of my brief session today, and I hope that's given you an understanding of the features and benefits that come with a distributed SQL database. There's another slide following this one which gives draws your attention to some references that you might find helpful, including some further reading, and there's a link there to download the NeoDB Community Edition. Please go ahead and download that and play with it and familiarize yourself with NeoDB and find out how it works in cloud and distributed environments. But please note that whilst you can add as many TE nodes as you wish for scaling throughput, you can only use one SM. You can't have more than one storage manager with the Community Edition. So I guess coming up to the last part now, which is questions. Sam, do we have any questions? In fact, maybe I can look on the chat and see if I got any questions.
Apologies, I was on mute there. We do have a few questions. So I'll start with this one. Since SMs and TEs, storage managers and transaction engines, are separate, can they be scaled independently Do they have to maintain a specific ratio?
No, no. As I said before, you're looking for redundancy in the no single point of failure distributed model. So ideally, you'd want more than one storage manager and more than one transaction engine as a minimum basis. But there's no link tying the numbers together. You can scale out as many transaction engines as you need just to support throughput, and you can have as many storage managers you need to give yourself or guarantee the redundancy or the data locality that your application needs.
Okay. If you're running only one TE and one SM, where is the built-in redundancy?
Right, so that goes back to the previous question. You need to have more than one of those to provide a no single point of failure. If you only have one of each, then if you lose the TE, you lose the transactional processing. And if you lose an SM, you lose your storage. So the minimum configuration for resiliency would be 2 of each.
Okay. How do you guarantee ACID properties while maintaining performance?
Well, that's atomicity. So atomicity is consistency, isolation, and durability. How do we maintain those with performance? That's a kind of a deeper subject to get into, and I'd be more than happy to share more knowledge about that. But because we're a distributed database, elements of data occur in more than one place in the cluster at any one time. So a piece of data can be sitting on disk, and it can be in a storage manager, and it can be in memory on more than one transaction engine. Now, we're also a multi-version concurrency control database, and the way that we store data in the database allows us to store multiple versions of a copy of data at any particular time. So that's kind of a deeper subject to get into, and I'd be more than happy to entertain that in more depth, but it's a bit difficult to cover off very quickly at this level. But yes, all the ACID properties are guaranteed within Nuo.
Awesome. The next question, do you have a concept of virtual databases that is decoupled from the transaction layer, or is the database dedicated to the entire transaction and storage layer?
No, you can have separation. For example, if you're thinking about, for example, a multi-tenancy situation where you've got more than one set of users in a single database, and you want to be able to ring fence some of that compute capability so that different people are not different workloads and different users are not conflicting with each other. NeoDB's got very flexible deployment options that allow you to do that. So we're not just talking about workload separation. You can also separate out applications and ring fence them and their physical resources.
Okay. Next question. How do you integrate data mining technology on NeoDB databases?
Well, we're primarily an OLTP database, and that's our sweet spot in online transaction processing. So systems of record, databases of record, that kind of thing. Ideal for tier 0, tier 1 systems, for example. We don't consider ourselves a data warehouse as such, and we're not in terms of data mining. Change data capture, that kind of thing, those features, you wouldn't find them in NeoDB at this point in time, although who's to say they won't be coming later in the roadmap. But at the moment, the primary focus and primary area of operation is as an OLTP database.
Okay. Is the NeoDB database tied to any specific cloud provider?
No, and that's one of the beauties of our portability, is that we can happily run on Azure, on Google, and on Amazon AWS, and you can even build a cluster where different components of your database are sitting on each of those 3 cloud providers. For example, we're totally cloud agnostic, and it's for this reason that we preserve your ability to avoid vendor lock-in, so that if, for example, you were using one of the proprietary databases and they just told you that they were going to increase the prices, your choices would be limited. With NeoDB, you can take your database with you. You can move from on-premise to cloud, you can move from one cloud to another, so it's very, very portable.
Awesome. And that also just answered the last question we had here. If we're not ready for the cloud, can we start on-premise and move to the cloud?
Yeah, and maybe someone came in who didn't hear the part of the presentation where I touched upon that. So yes, you can start out by building your database on premise, And when you're ready, for example, to move to cloud, you can stretch that cluster out to the cloud and start building capacity in one or more of the public clouds, so that your cluster now is spread over, not just on premise, but also into the public cloud as a hybrid architecture. So yes, you can definitely take your database with you when you're ready.
Awesome. If anyone else has any more follow-up questions, we'd be happy to answer those for you. But if not, thank you. Thanks, Simon. Thanks for a great presentation, and thank you to our audience for attending our session today. We hope that you found the webinar informative and useful, and be sure to visit nuodb.com for more information. Thanks again for attending. This concludes today's webinar.
Thank you. Bye-bye.